Now, after studying the qualitative and the quantitative aspects of the electrolysis, now let us study how we can predict the products of electrolysis. Yes, when we are doing the electrolysis of the electrolytes in the fused or in the molten state, what all are the products we will be getting at the cathode and the anode we can easily predict. See, the products obtained or at the respective electrodes, they depends on certain factors. Now these factors includes the standard E0 reduction values of the different species which are undergoing oxidation and reduction at the respective electrodes. Second factor is the electrode used, and the third factor is the concentration. Now let us take different examples to study these factors one by one. Let us take first example of NaCl aqueous. See, when this NaCl aqueous is electrolyzed, we know we will be getting Na plus ion and Cl minus ions. Now let us see what happens at cathode first. We know cathode is the one which is connected to the negative terminal of the cell and is having a negative sign. Now here reduction takes place. So sodium ion approaches here, it can accept electron and get reduced to solid sodium. Similarly, since it's an aqueous NaCl, we have water also. So water will also go to the cathode and it can also accept electron like this, and it can also get reduced to form hydrogen gas and can form OH minus ions. So it can be balanced like this as such. Now the question comes is, out of these two species which can get reduced at cathode, which will actually get reduced? For this we have to see their E0 reduction values. Now E0 reduction value of the sodium is minus 2.71 volt and the E0 reduction value of the water is minus 0.83 volt. So now what we can find out is, definitely the species with the higher reduction potential will get reduced at the cathode. This is what is the first factor is. Species with higher E0 reduction potential will get reduced at cathode. Similarly, the species with higher oxidation potential or lower reduction potential will get oxidized at anode. So out of these two, which is having a higher reduction potential? This water. So this gets reduced, this doesn't get reduced, sodium ions remains as such in the water. And see, that is why if we have to take out, or if we have to obtain a reactive metal whose E0 reduction value is less than this one, we cannot do their electrolysis in the aqueous medium, because once we are doing their electrolysis in the aqueous medium, definitely water reduction potential is being higher, always gets reduced, leaving that metal in the oxidized state. So this is the first information we can get from this example. And always the species with higher reduction potential gets reduced at cathode, species with lower reduction potential gets oxidized at anode. That's the basic of the first factor. Now let us see. So now we know we will be getting hydrogen gas at cathode when we will be doing the electrolysis of aqueous NaCl solution or brine solution. Now let us see what happens at anode. Now anode is positively charged, so chloride ion can approach there, can form a chlorine gas and get oxidized to chlorine gas, giving out 2 electrons. Simultaneously, what can happen is, water can get oxidized to oxygen, giving 4H plus and 4 electrons like this. So water can also get oxidized and can release oxygen gas. Chloride ion can also get oxidized and can release chlorine gas. So these gases will escape out. Now the question comes is, which out of these two will escape out at the anode? For this we have to refer to their E0 reduction values. It's 1.36 volt and its value is E0 reduction value is 1.23 volt. So if we see purely the values, E naught reduction values of these two species, what we find is the water is having a lower E naught reduction value. So its oxidation potential is higher. So it should have got oxidized during the electrolysis. But this doesn't happen. This doesn't mean that the basic factor or the basic condition which I have told you that the species with the lower reduction potential will get oxidized is wrong. It's not wrong. What is the problem is? The problem is of a concept which is called over potential. What is over potential? See, what happens is certain redox reactions are kinetically slow. Now, in order to actually make them take place in a faster way in the normal regular course, we need to give them certain extra amount of the voltage. Now, there are certain gases which takes extra voltage to escape out in the form of a gas, which is extra to their normal E naught value. Now, that extra voltage we take is called over potential. And this extra value is to be added to their E naught value so that therefore their E naught becomes much larger. And that is why water is such a gas, or oxygen is such a gas which is obtained by the oxidation of the water, which involves over potential concept. And that is why when that over potential value is added to this, the E naught reduction value of chloride ion becomes lesser than that of water. So it is the chloride ion which gets oxidized. So remember, therefore, whenever we will be doing the electrolysis of chloride salts, aqueous chloride salts, always at anode you will be getting chlorine gas, because always there will be a clash between chloride ions and water, and out of these the chloride ions will be the one which will get oxidized. So this is what the one example. Let us take the second example of copper sulfate aqueous solution using copper electrodes. So let us see what happens when we do the electrolysis of aqueous copper sulfate using copper electrodes. We are not using inert electrodes. We can discuss simultaneously what would have been the products if we have taken the inert electrodes like platinum, which doesn't participate in the reaction, or what happens when we are using copper electrodes. So we know copper sulfate, when we'll be doing its electrolysis, gets dissociated. Actually it's there in the water in the form of copper ions aqueous and sulfate ions aqueous. Now what we find is at cathode, let us see the first. The cathode is basically the one where reduction takes place, negatively charged species. So copper comes here, accepts electron and get reduced. Its E naught reduction value we know is 0.34 volt. Similarly, water can accept electrons and get reduced to form hydrogen gas and 2 OH minus ions, and its E naught reduction value is, we know, is minus 0.83 volt. Now there is no other third species which can get reduced, because your cathode, if it is of platinum or of copper, it doesn't make any difference because both of these are in the reduced state. So always remember, the electrodes doesn't make any difference at cathode because they are always present at the reduced state. Now out of these two species, the one with the lower reduction potential, higher reduction potential gets reduced first. So which species is having a higher reduction potential? It's the copper. So what we find is water remains as such, and it is the copper ions which get reduced at the cathode. That is why when we are doing the refining of coppers using copper sulfate electrolyte, always the cathode is taken as the impure copper one. Sorry, it is taken pure, because the pure copper gets deposited at the cathode. Now let us take the anode first then. Now here what we can find is sulfate ion can approach and can get oxidized. The sulfate get oxidized to S2O8 2-, which is called peroxydisulfate ion, and releases 2 electrons. Its E naught reduction is 1.96 volt. Simultaneously, we have water also, which can get oxidized by giving O2 4H plus 4 electrons whose value is E reduction is 1.23 volt. Also, since suppose if we have the platinum electrode, then definitely these two will be the reaction which will be taking place. Platinum will not participate, and the one with the low reduction potential is the water, and then what we get is we get oxygen gas at anode and the copper as the at the cathode. But since if we are not using inert, if we are using copper electrode, copper anode is of copper, then what happens is the copper can also get oxidized like this, and it's this oxidation reaction will have E naught reduction value opposite of this one, that will be minus 0.34 volt. Now let us see which out of these is having the lowest E naught reduction, highest oxidation. It is the copper. So this gets oxidized, these reactions doesn't take place. So what we find is it is the copper anode which gets oxidized, and it is the copper electrode which copper ions which gets reduced at copper electrode at cathode, and therefore we take anode always as impure copper, and the electrolyte taken is copper sulfate. So basically this is the refining of the impure copper to pure copper, taking copper sulfate as the electrolyte. Now let us take another example of sulfuric acid. And by this example, we will study the effect of concentration. Now, sulfuric acid's electrolysis, it's done at two conditions, concentrated or dilute. Now we know when it will dissociate, it will give us H plus ions and sulfate ions. This we already know. Now let us see at cathode what we find is. See, if at cathode, if the solution is concentrated H2SO4, we will be having a lot of H plus ions, concentration is high. So what we find is H plus ions gets reduced, and we know their reduction potential is 0. So there is no point in any of other conflict in this case. Whereas if it is dilute H2SO4, H plus ions concentration is low, what we find is it is the water which gets reduced, forming hydrogen and OH minus ions. So there is again no conflicting ion with this. So we get this. So in both these cases, if it is concentrated or dilute, we will be getting hydrogen gas. But what happens at anode? At anode, what we find is it will be the sulfate ion. Let us see the concentration. If it is concentrated, it will be the sulfate ion which get oxidized to peroxidized sulfate ion, and it forms this. And remember, this is the reaction which takes place when we have a concentrated one. Though its E naught reduction is 1.96 volt, and if we compare it with water, which is forming O2 plus 4H plus 4 electrons with the E naught reduction of 1.23 volts, we can make out that, okay, fine, this is the species which is having a lower E naught reduction, so it must get oxidized. But no, since it is concentrated, there is a lot of sulfate ions, this reaction doesn't take place. We get peroxidized sulfate ion, which on adding water forms hydrogen peroxide. The same reaction which you have done in your class 11 in the preparation of hydrogen peroxide. And therefore, we get what? Peroxidized sulfate ion. If the sulfuric acid taken is dilute, sulfate ions concentration is very low, so we have only this one reaction which is going to take place. It forms oxygen, H plus ions, 4 electrons. This is the one which takes place. So we get, when it is dilute, oxygen at anode and hydrogen at cathode. If it is concentrated, peroxidized sulfate ion at anode and the hydrogen gas at cathode. So this is how we can predict the products of electrolysis.